Okay, so this is the answers to 3-3, your homework. Systems of linear inequalities. Take a quick look. I'm going to go through them kind of quick. This is number one. You saw it yesterday. Y greater than x plus 2. That's this dashed line right here. Y-intercept of 2. Slope of 1. That's, I know you can't, this is just a quick version of up 1 over 1, dashed line, greater than, we would be shading above. This next line has a y-intercept of 1 and a negative 1 slope. That's down 1, right 1, or up 1, left 1. It is solid because the equal to sign, and it's shaded below. So below the solid line, above the dashed line, put your solutions right there. That's number one. Everybody say you got it. Number three. Number three, one of them was written in y equals mx plus b form. This was standard, so we subtract the x and we would have y. This right here. This is this. Y less than negative x plus 5, you subtract that x. So, this one right here, plus 5 is right here. 1, 2, 3, 4, 5 is a y-intercept. Negative slope, that's down 1, right 1. Over and over and over, that's at negative 45, right? Right? I love negative 45 dashed, because there's no equal to. Less than, so we shade it below. The other inequality, y-intercept of negative 2. Slope of 3, that's rise. 1, 2, 3, run 1. 1, 2, 3, run 1. This is this dashed line. It's shaded below. Below both of them, below this one, puts this as your solutions. Got it? Got it. Which one of those will be on your quiz? What do you think? This is number 5. 5, they were both given to you in standard form. That was this one and this one. Given to you in standard form, we did the math. This one would be y less than 3x plus 3. This one would be y greater than negative x minus 1. There is the positive 3 y-intercept with the 3 as a slope. Here's the negative 1 as a y-intercept with the negative 1 as a slope. They're both dashed. Below this line, above this line, puts this as your solutions. Got it? Got it. Let's keep going. We're going fast. Number 7. 7, we were given a couple inequalities that required lots of algebra, and we ended up graphing this line and this line. Those are the two lines that, or inequality lines that we graphed. First one, minus 3 is right here, slope of 2. This one, y-intercept of 3/2, or that's 1 1/2. Slope of negative half, so we go down 1, right 2. Down 1, right 2. They're both dashed. We shade below both. So again, that's right there as your solutions. How many of you want that one for your quiz? That one had a lot of algebra, didn't it? Just to get here. Maybe. 9, we get into an easier world, a different world. Solutions are greater for y are greater than 2. Hang on to this equation or this inequality. Today's linear stuff that we'll do will look a lot like 9. So if you can do 9, that'll help you for today. So y is greater than 2. That's this solid horizontal line. Everywhere y is 2, we're shading above. And then here is, what do we call that kind of graph? Somebody tell me? An absolute value graph. Is that the parent function, or is that one been translated? Yep, right here, up, you guys. Is this the parent function, or has this been translated? That's the original parent function, isn't it? It doesn't have what two letters? What are the things that make it move? H and K. Very good. We don't have an H or a K. We also don't have an A to stretch it or make it wider. So that's the original parent function, vertex at the origin. Solid line, both of these are solid lines, both above, that puts that as a solution. Okay, number 11. We don't do 11, do we? And we don't do 13. Where's 11? I'm missing 11. Uh-oh. How dare. Hold on, let me see if I have it. Nope. I'll put it right here. Number 11. Shame, says the student. The student says shame. Number 11 has this one, y greater than the absolute value of x. That is, here's the absolute value one again. Greater than, so we'd be shading above. 11 also would have y greater than 2x plus 1. You see that? How do I get y greater than 2x plus 1? What did I do? What did I do to make it that way? Look at your paper, look at your homework. That isn't what it has. What did I do to make it that way? Add 2x. Hey, good job. I added 2x. So that has a y-intercept of 1 right there. Slope of 2. Rise 2, run 1. We'll put it right there. And I feel like we had this one yesterday. Did we do it yesterday somewhere? Okay. Shading above. So this ends up being your solutions. This little area is cut out. All right, we skipped 13. Let's go to 15. This is where you didn't get to yesterday, was it? Right? Maybe? Maybe. 15, we have y greater than negative 2x plus 2. There's the y-intercept of 2, the slope of down 2 over 1. So that's the line negative 2x plus 2. That's the first one. The second one starts with x minus y greater than or equal to 3. Then you'd have negative y greater than or equal to negative x plus 3. And if you divide that negative off, you end up with y less than or equal to a positive x minus 3. So that's why we have a negative 3 as a y-intercept, rise 1, run 1 as your slope. And it is shaded below, so we're above. I almost put this as the solution. This is incorrect. The solution is not there. We're above the dash line and below this solid line, so over here is the solution. I made it, when I put the solutions on this, when we did this, I made it wrong, so I had to fix myself. Hopefully when you do it on your test, you don't make a mistake like I did right here. So above the dash line, below the solid line. 17, they're both already absolute, or they're both in slope-intercept form. We have the first line has a y-intercept of negative 1, slope of 5. 1, 2, 3, 4, 5 over 1. So this is your first line. It's dashed, shaded below. The second line has a positive 7 as a y-intercept. I kind of messed up here. Look at this, guys. 1, 2, 3, 4, 5, 6, 7 end up, oh, that's horrible. It's way up into that dude. And the slope of negative 3, down 3 over 1. It is a solid line, shaded above, so this is your solution. That one's not too hard, was it? Okay, 19. 19, the first line is this one. No. Yes. You subtract the x. Positive 2 is a y-intercept. Negative 1 is a slope. Down 1 over 1. It's dashed, shaded above. The second line is this one right here. Subtract the 2, and you also have to divide the negative off the y, so it makes it now greater than. How many people flipped their inequality? Did you flip it? Good job if you raised your hand. So it's a negative, from a negative 2x to a positive 2x, and from a positive 1 to a negative 1 here. So negative 1 is your y-intercept. You would rise 2, run 1, and shade above. So above, both of them are above. This is why your solutions are here. We're almost done. 21, this one's cool. 21, this line right down here is the y greater than or equal to negative 2. There's your horizontal line at negative 2. We're above it. And then look at this. What is this? What does this absolute value one have? What letter? I'm pointing to that number. What is that number taking the place of? H for hooray! Horizontal shift. We have an H. We went to the left 3. Why did I go left 3? Never trust your ex, baby. So yeah, and we're flipped. 45's down. Hey, you know what's so funny? Look at me, guys. Look at me. This is what's funny with you guys. This is where I think you guys crack me up. You will do one problem like this right here. I'm circling it. You will do one problem like that, and the very next line you think has to be a V-graph. The only V-graph, the only time you have this V-graph is if it is absolute value, right? Right? Can somebody tell me, I want to do this. This is a game. Here, I'm going to do a quick race. Look at me. Get your pencil in hand. Here's the race. Graph this. If you can graph it, as soon as you're done graphing it, put your pencil in the air. It's kind of like you're a calf roper. You get the rope tied, throw your hands in the air. This is what's funny. You'll do this, and then you'll forget how to do this. Graph this. Graph that right there. Put it on there as fast as you can. Pencil in the air. All right. Hopefully, I saw some quick hands. Hopefully, I'll just use this one. You just go right through there. Now, that's horrible. I'm so sorry. Pretend that's straight. That's right. It's that simple, isn't it? It goes to the origin, slope of 1, boom. But what's so funny is sometimes we'll start doing these absolute values, and then we'll take something like that, and we go, where do I go, Mr. Bush? It's just a straight line. Still. All right, so good job. Last one. Here's the last answer. If you have a graph like that, then good job. I had one student come up to me and goes, Mr. Bush, is this right? Is that right? Yeah, that's right. You have the line y greater than x. Here's that line, dashed line. Y greater than x. That's just like that. 45 through the origin. And then we have this one right here. This one came from the equation. Y less than the absolute value of x plus 2. X plus 2 sends it 2 to the left, and it's less than, so it's below that V graph and above that. So these two lines, they're actually parallel right here. I know mine doesn't look like it, but it should go on forever up here. There's a shaded area that goes on forever, and then we'd turn the corner, and then everything over here would be shaded. Ain't that a neat little shading? All right, we got her.